will
Let's
now
go ahead
be
and start.
recorded.
Today we'll focus LangChain memory. Today we'll focus LangChain memory. So far we created many agents. Okay, so far we created many agents, right? Or LangChain agents, legend agents, and those are stateless. Okay, those are stateless. What does that mean, stateless? We'll understand now. Today we are focusing LangChain memory. That is the concept. So far we created many LangChain agents. Those are stateless. What does it mean? Stateless means it cannot remember. That means agent cannot remember, okay, previous conversation information. Previous conversation information. What does that mean? We'll see. So if you see the code, this is how we coded till now, right? These are the examples we have coded before. First we loaded the environment variables from .env file. That means in the .env file we have many environment variables. Those are all get loaded. Then we imported the necessary libraries like a OS library, all those things. Then we initialized the LLM. That means we initialized the model means we created an object for this chat OpenAI. These are all we covered before. Then we created a LangChain agent using create agent, and we passed our model information, all those things. Then we displayed the agent object structure. Then we invoke the agent. We invoke the agent by passing the message. We invoke the agent by passing the message. Now if I run this program, this is working fine, and my request went to the model. You can see my prompt go to the model. The prompt right now is what? My name, ChennaRRRS. That is the one it is going to the model. Now model is trying to say, hey, ChennaRRRS, hello ChennaRRRS, how can I assess you today? Like that it is responding back. So far we are good. So that means there is a request to the model is responding. So far we are good. And I said these are stateless. That means it cannot remember the previous conversation information. What does it mean? Let's prove it. So I will copy this one more time, and I will invoke the model with one more prompt. I will invoke the model with one more prompt. That prompt is nothing but what is my name? I already told my name is ChennaRRRS. Next time I am asking what is my name. Let's see whether model remembers or not, whether the agent remembers or not. So I just ran this. Okay, first time. Okay, good. Request went to that. Okay, then when I ask what is my name, it is saying I don't know. Let's do this. I will take this into a new cell. Okay, I will take that into a new cell. So this when I run this, my name is ChennaRRRS. You can clearly see that hello ChennaRRRS, how can I assess you today? That means it is good. Now I'll just go here and do a one more request, one more invoke, one more model request. There I am saying what is my name. Now if I run this, you can see it will tell that I don't know your name. So that means what? The request whatever is going is a stateless that can remember only that current information. It cannot remember previous information. It cannot remember previous information. That's the meaning of stateless. So that's why I said whatever agents we created till now, LangChain agents, whatever we created till now are stateless. It cannot remember the previous conversation. But in real applications, we want agents to remember. We want agents to remember previous conversation, right? Previous messages. That is very important. Okay, that is very important. This is very important. We want agents to remember previous information, previous message conversation information. For example, let's go to what does that mean? We want agent to remember previous conversation information. Let's go here, platform openapi.com, Right now, whatever agents we created, it is not remembering. This is what we have seen. Now I am just showing what is the meaning of remembering. Okay, what is the meaning of remembering? I am just showing. I am just going out of the box platform open API. There we have a chart, right? This is the out of the box platform OpenAI.com. So there you have a chart. So here I will type tell about India in one line. So you can see I got the response. That is the first request. Now I am saying tell about Python in one line. Tell about Python in one line. See, it is getting the answer. Now, what is the guarantee that it is remembering previous conversation messages? I will type next request as what I asked before. What I asked before. Now you see, it is clearly telling that, hey, you asked two things. One is tell about India, tell about Python. That means it is able to remember the previous conversation messages. For example, I will tell one more time. Okay, tell about AI in 2 lines. Tell about AI in 2 lines. I got the answer. Now, what is the guarantee that it is remembering previous conversation messages? I will do continuation. Give me, okay, give me big news about it. Give me big news about it. What is the meaning of about it? What is the meaning of it? The previous conversation. Let's see whether I am getting the answer or not. Let's see I am getting the answer or not. Give me big news about it. Now you see, it is telling that the big news about AI. See, it means AI. It recognize, it understand, it remember previous conversation message. That's why the it referring the AI and it is giving the information. This is the meaning of so this is the meaning of remembering previous conversation messages. This is very important in the real time, right? This is very important in the real time. But right now, whatever agents we created are stateless, it is not remembering. Okay. Whatever agents we created are stateless, it's not remembering. Then what to do? Okay. Then what to do to make remembering? For that, we can use memory concept. We can use memory concepts and this we can implement in many ways. This we can implement in many ways. That means memory concept we can implement in many ways here. Memory concept we can implement in many ways. So the first one is in memory, SQL memory, like that. And also one more point is we can handle this memory concept, this memory implementation using checkpointer. There is a using checkpoints, using checkpoint or checkpointer. So people say that as checkpoint or checkpointer, whatever it may be. Okay, we'll see the example for it. Okay, before we see the example, so you need to understand there is a checkpoint. So that means from where to where we need to remember. That's called a checkpoint. Checkpoint means what? Starting, ending, like that. Good. Now, as I said, right now, as I said, this memory concept we can implement in many ways. This memory concept we can implement in many ways. We can implement using in memory. Okay, so in memory. Second one is okay, SQLite database, using SQLite database or Redis database. In memory means temporary memory. It's stored in the RAM. Okay, in memory means temporary memory. We'll see the examples for this. Temporary. So that means it will store in the RAM. SQLite means local persistence. Local persistence. Then third one is there is a Redis. Like this, many are there. It's kind of a fast caching implementation. So here you are going to store the information in the RAM. Here you are going to store information in the local system. Here it's kind of a cache. But in the production cases, we will be using something like a cloud and all. Fourth one is Cloud DB. So this generally we will use for production purpose. Like this, we can do in n number of ways. Don't think that these are only ways. This is for production purpose. Let's recap this point one more time. Whatever agents we created, those are till now are stateless. It's important for us to make them stateful. It's important for us to make them stateful. How do I do that? It's important to make agents stateful. Okay, for that, how do I do? We can use a concept of memory. We can use a concept of memory. This we can implement using checkpointers. This we can handle using checkpointers. And finally, this memory checkpointers we can implement in n number of ways. First one is in memory. In memory means the information is stored in the RAM, means temporarily. We'll see the example also. Or we can use some databases like SQLite database. That means the information conversation stored in the local persistence, local system. And we can use Radish. It's like a fast caching mechanism. Okay. For production purpose, we can use cloud databases and so on, so we can use cloud databases and so on, so. Then one more point is we can store the information, or memory can be short-term memory. Memory can be short-term memory or long-term memory. Okay, long-term memory and check pointers. So check pointers means what? Where to start, where to end, like that. So short-term memory means just now I told you, in memory. That's a short-term memory. We'll see the example. Okay, long-term memory means where you can store permanently, like a SQLite database, cloud database, like that. Then what is the check pointer? Check pointer is the one which tells, okay, oh, this is the place, save the state. Use it to save the state and resume it. So that means this is where you start, this is where you end, and this is where you can recollect it. Check pointer. That means if anyone asks what is check pointer, okay, what is a check pointer? So it will tell that where to save the state, save state, and resume execution, and finally persist the workflow. Persist the workflow, like that. So that is about the check pointer. We'll see the real example for it. So in a simple word, LangChain plus agents plus memory. LangChains plus agents plus memory is nothing but a agent which can have the remembering capacity, knowledge capacity. Based on that, it can perform the actions. Example, I told tell about it, or big news about it. Big news about it means it remember the previous conversation messages. Based on that, it is taking next action also. That's about this particular concept. Now let's see the notes for it, then we'll continue the exercises. So memory, as I said, it's a stateless. Every time it will feel a fresh request. But in the real applications, we need to remember the previous messages. Okay, how to handle this? By using check pointer. Check pointer is what? It stores, reloads, continues the execution, and so on. Now, types of memories: buffer memory, window memory, summary memory, token memory, like that. Check pointers. Okay, in memory, SQLite, Redis, cloud. Then production purpose, we will use this cloud DB, like that. Next, short-term memory, like a RAM. Long-term memory, put in the databases. Short-term memory will have just that current instance running messages, like a RAM. Once you restart, it will gone, like that. Okay. So long-term memory means you are going to put in the database or local file. So therefore you can access anytime. What is the check pointer? Just now I told you. It will help us to save the state, then continue the execution, resume the execution, persist the flow. Now LangChain plus agent plus memory allows AI agents to remember the conversation, store the knowledge, perform the actions, resume the resume the workflow like that. Different advantages we can get it. That's why I said agent is more than just answering the questions. Agent is not just a question answers. Agent is more than that. What is the more than that? We have seen a number of examples before. Now we are starting adding the memory for the agents. Now we are starting adding the memory for agents. Okay, all right. Now let's come back to the exercises. Let's come back to the exercises. If you see, whatever code we have done till now is just stateless, right? If I execute this, I got the answer. Then in the next request, if I ask what is my name, it is telling I don't know. That means it's a stateless. Now let's make this as stateful. Okay, let's make this as stateful. I will do using, we can implement stateful in n number of ways, right? We can implement a memory or statefulness in n number of ways. First way is I will use the in-memory mechanism. First way is I'll use the in-memory mechanism. Okay, in-memory server. Sorry, saver. In-memory saver. In-memory saver is a short-term memory. Okay, short-term memory. It cannot remember for long, and it can be used by using can be done using checkpointers. Using checkpointers, and it will keep the information or state in RAM. It will keep the information or state in RAM. So that means if you restart your application, then everything will be gone. We'll see. Okay, so this is the first solution. Okay, first solution one, using in-memory saver. Let's use the same program and see how to do using in-memory saver. I'm just copying this program, going to the new cell and pasting, and this is okay in-memory saver. I just added a comment, nothing more than that. Then we loaded the environment variables, we imported the necessary libraries, then initialize the model. Okay, create a agent, execute the agent, or invoke the agent. This is what we have done before. Now we want to add the memory for it by using in-memory saver. By using in-memory saver. So then what we can do is that, okay, by using in-memory saver, so what we can do is that we are trying to create the agent, right? So before agent, you need to import that. We can import any place. Okay, I'm just importing here. So there is a LangGraph. LangGraph. What is the LangGraph? We'll see later. But for now, you can just assume that this is the library. Checkpointer.memory. Checkpointer.memory. Import in-memory saver. Import in-memory saver. This in-memory saver, you need to pass to your agent. That means when you are creating the agent, pass this. So therefore, I am saying check pointer. You can see there is a check pointer equal to this in-memory saver. That means I want to save the information using in-memory. In-memory saver will use RAM. So therefore, this is the additional step. Okay, good. Okay, so far good. Then what you need to do? You need to remember, right? You need to remember. So I can chart today, I can chart tomorrow, I can close, I can come back like that. That means we can do many conversations. So in that case, what you need to do is that before you invoke, create some configuration with let's say RRRS. Okay, RRRS configuration. With what? We can have a multiple configuration also. With what? Sorry, create a configuration. One second. Create a configuration and specify, okay, configurable. There is something called create a configuration. Let me do this way. And configurable. Configurable. That is just a variable. And what you want to configure is you need to specify thread name or thread ID, thread underscore ID. Why I am using thread ID? Let's say RRRS memory -1. So using this thread ID only, I can capture what happened before. Using thread ID, I can store the information. Using that thread ID only, I can retrieve. Okay. So therefore, for every invocation, pass the thread ID. For every invocation, pass the thread ID. Okay. For every request, pass the thread ID as a configuration. Config. Okay. Config equal to, you can pass this configuration. What is the configuration? It's just a thread ID. What is the configuration? It is just a thread ID. That's it. Okay, all right. Now I'll just put the semicolon here so that now you can see I run. So if I run, no errors. Please observe here so far. What did we do? We just mentioned when we are creating a agent, I mentioned I want to use in-memory saver. That means I want to use or I want to put my information in RAM. That's the one change we have done. Then we are trying to invoke the agent. When we invoke the agent, we will pass thread ID information. We will pass thread ID information. That means in-memory saver save the information, right? It can save your information, it can save my information, it can save Chenna information, it can save RRRS information. How to retrieve it? How to retrieve it? Using thread ID. That is what I am passing to this particular request. Now, whenever you want to use this previous information, pass the thread ID. Retrieve using thread ID. Retrieve using thread ID. The concept is like this here. Let's say there is an agent. This is the agent or model. Okay, model. Now you have agent 1, agent 2 like this. Agent 1, agent 2 like this. Now you are sending a request. When you send the request, by default it is stateless. Now I am telling, hey, whenever this request is going, add the information in memory, that's called RAM, and put that information with the thread ID. So that whenever I want, I can access that information using that thread ID. Whenever I want next time, I can access that information, whatever stored in the RAM, using that thread ID. That's it. That is what exactly we are using. So therefore, whenever I am trying to invoke, I said, okay, consider this thread ID. Consider this thread ID. Now I ran this. Okay. Now ChennaRRRS. My name is ChennaRRRS. My name is ChennaRRRS stored in the RAM. My name ChennaRRRS stored in the RAM. Then with this thread ID reference. With that thread ID reference. So next time when I want it, I want to use it. How do I use it? Let's see. How do I use it? Let's see. Okay, I'll just create a new cell. Sorry. I'll just create a new cell and do one more request or invoke the model again. Then you can ask a question. I already told, okay, my name is ChennaRRRS and it is stored in the RAM in memory saver using RRRS config. What is the RRRS config? Using thread RRRS M1. Okay, in the next request, I am saying, okay, what is my name? in the next request, I'm asking what is my name. Now earlier it was saying I don't know. Now let's see what happens. And you need to pass this. Okay, you need to pass the thread ID also. Then only it can go and see. Okay, then only it can go and see is there any information in that. Yes, it can access. It can use it. Now let's see. Okay, look at here, please. ChennaRRRS so on so on so. Then in the next request, you can see it is passing. What is my name? And you can see response. Your name is ChennaRRRS. That means it remembers the previous conversation. It remembers the previous conversation. It can remember the previous conversation. So that means there is a request 1, request 2. In the request 1, I said, my name is ChennaRRRS. In the request 2, I asked what is my name. It is able to get previous message and tell that, hey, your name is ChennaRRRS. Okay, that's it. That's it about this. Next. Now, what is the challenge here? What is the challenge here? So this is a in-memory saver. In-memory saver, keep the information in the RAM. In-memory saver, keep the information in the RAM. So this is working fine here. This is working fine. Okay. So this is working fine, but there is a challenge. What is the challenge? Right now we are using in-memory saver. This in-memory saver keep the state or information in RAM. So that means that information is available. Okay, that state is nothing but the information. That state available as long as your Python process is running. As long as your Python process is running. So that means in a simple word, you close the, okay, you close this editor, open it again. You cannot get back. So it's not permanently persisted. It's not permanently. It means what? State. State is not persist. Okay, persist permanently. Or state is not persist between sessions. Or not persist between sessions. What does it mean? The meaning is, let's say right now this is a Python program running and it is used. Now I'll just close this, open it again. Okay, close this, open it again and run it. Okay, so this is the one, right? You can see I'm using the thread ID and okay, this is the thread ID. I'm asking what is my name. Okay, I'm asking what is my name. Look at here. Okay, so come here and say what is my name. Let's see. See, I don't have access. I don't have your access. Like that, it is giving the response. So the meaning in a simple word is this information, whatever stored in the in-memory saver, is available as long as your Python process is running. Once Python process is killed, that information is not available. That information is not available. That is the challenge. Then what is our next question? Our next question is how to, okay, how to save the state. How to save the state between sessions. That means there is one session, you close it, come back, or your session, my session, or permanently in a simple word. How to save the state. State means that information between sessions. So question number 1 is how to save the state. How to save the state between sessions. That means I can use it in the current session or in the next session also. We'll see that exercise. Or how to store the state permanent. State permanently. So for that we can use databases. SQLite database like that. SQLite database like that. Now let's see how to do this. So therefore solution 2. Solution 2 is a permanent one where you will be saving the state using SQLite. SQLite database. SQLite database. It will save the state permanently. It will save the state permanently. How to do that? For that, what you need to do is that, for this, what we need to do is that there is a LangGraph checkpointer you need to install. So if you go here, this is what we discussed just now. Agents are stateless. Then how to make it as stateful? We can use short-term memory, and this is a long-term memory because it stored the information in the database. It's a long-term memory example. So short-term memory example is covered. Now we are covering the long-term memory. Okay, this is what done. So in memory saver put the information state in the RAM. So therefore we cannot access in the next session. So as long as Python process is running, it will be available. After that, it is not available. Then how to put the state so that it can be accessible in multiple sessions. For that we are using SQLite database check pointers. For that you need to install this here. So just copy that syntax and install it. So for this you need to install this particular library. Install LangGraph checkpointer SQLite. Install LangGraph checkpointer. That is the one you need to install it. Now installation is done. Once installation is done, now let's see how do we code. Okay, so for coding we are going to use SQLite checkpointers. SQLite checkpointers. So we already installed the SQLite database, right? We already installed there was one more installation done for SQLite database. We already done. Okay, now come back here. Come back here. So if I run this, okay, if I run, this is an in-memory saver example, right? Yeah. So if I run this, we got it. And using that thread, if I say what is my name, it is able to identify your name is this. It is able to identify your name is this. Good. If I close it, it is not available, right? So therefore, I'll copy this code again. Go to the new cell. I'll copy the code again. Go to the new cell. Pasted. Instead of in-memory saver, I am using what? Okay. I am using SQLite database checkpointers. SQLite database checkpointer. So for that, I install the corresponding library also. Okay, good. Now, common steps. First one is what? Load the environment variables. Second one is what? Import the necessary libraries. Import the necessary libraries. Now, do I need the in-memory saver? No, we don't need the in-memory saver. Instead of in-memory saver, what do we want? We want that SQLite checkpointers. So therefore, import SQLite 3. This is what I want. And from LangGraph, what is a LangGraph? We will discuss in detail in the coming days. For now, just remember that we have some library, LangGraph checkpoint dot. So that checkpoint we need to put in the SQLite DB. So import, import SQLite saver. Import SQLite saver. Like this, you can do it. Now this is the DB, right? This is the imports, okay? DB, we need to get a connection. These examples we have done before also. So that's why SQLite is a DB. So that's why we need to create a connection. So therefore, create DB DB is nothing but SQLite here. Okay, connection, and reuse it using checkpointers. Create a connection and reuse it. All these things we'll do with a checkpoint. Okay, all these things we'll do using checkpoints. Let's see how do we do that. So therefore, first thing is that you need to create a connection. So let's say RRRS connection equal to connection we need to create for SQLite 3 database. These are all we practiced before also. But yeah, do it again, no problem. Connect, and you can give the name. Okay, so let's say ChennaRRRS hyphen checkpoint dot ChennaRRRS hyphen checkpoint dot SQLite. That's the name I am giving. Okay, then you can give check underscore. There is a check underscore same underscore thread. Okay, false. That means for different sessions, different thread IDs get created. Different session, different thread IDs get created. Check same thread false. Okay, all right. So this is how it is. Next is let's say RRRS underscore check pointer equal to now this SQLite server, SQLite saver. Then say that connection equal to this connection. Connection equal to this connection. Okay, you can see there is a parameter connection. If you go inside this also, if you come down, this is how the coding. You can also, yeah, this line number 87. Instead of using the existing one, I am using my connection. Instead of using the existing one, I am using my one, like that. Then you need to, okay, so that's about the RRRS checkpoint. This you need to set it up. That checkpointer, that means SQLite checkpointer, you need to set up. That's it. So these are the steps you need to do. So in a simple word, this is nothing but activating SQLite checkpointer. Activating SQLite checkpointer. That's it. Now come here. Okay, come here. Now we have a creating agent, right? We have a creating agent. In the agent, now tell me, do I need to pass in-memory saver or SQLite? SQLite. That you can pass it. Okay. So RRRS underscore checkpoint. That you can pass it. So here we are what we are doing line number 18, 19, 20 is nothing but activating SQLite checkpointer. Activating SQLite checkpointer that I am passing to my agent. That's it. Next, so whenever we are sending a request, okay, and that I am passing to my agent, that is correct. Now you are trying to create this configuration, right? For that you can use thread ID and you can pass the same thread ID. That's it. Now let's see. I says, okay. Now I send a request. My name is ChennaRRRS. It is stored. Now in the next cell, I'll use let's use different thread ID. Let's say this is 2. RRRS memory 2. So I just ran it. That got stored. Now I'll use that configuration. Let's say I'll say this as configuration 2. Configuration 2. Because we have configuration 1 also, right? So let's use the different names so that you can see clearly. I'll do one thing. I'll just close this and open it again. I'll just close this and open it again. Okay, good. Now, okay, if you come down, we activated the check pointer, SQLDB check pointer, we activated it, and we are using as part of my thread. We are using as part of my thread. Now I'll just execute this once. I will just execute this once. Now you can see it is putting that previous conversation. Okay, let me change this to different number. Change this to different number and click on save, run. Now you can see this information right now saved. Good. Now go here and say what is my name. Next request. What is my name? Okay, you can see it is telling your name is ChennaRRRS. It is telling your name is ChennaRRRS. Good, right? That's it. Now you close it and open. This much of information right now is available. This much of information right now is available. That means ChennaRRRS is available and it is able to recognize the ChennaRRRS also. Now I am closing this session. I close that Python program. I close that Python process. Let me open this. Coming back tomorrow. Assume that I am coming back tomorrow. Okay. And I am coming back tomorrow. And let me. Okay. I am coming back tomorrow. And let me run this. Okay. I am coming back tomorrow and sending one more request. Let me send one more request. This is what available yesterday. Assume that this is what available yesterday. Let me create one more request. Okay. When we create one more request, make sure you are giving that thread ID same. Now, instead of what is my name, it remember already ChennaRRRS, right? It already remember ChennaRRRS. What I asked before. Pass the same thread ID. Just run it and see whether we are getting. See, you can see. This is the first ChennaRRRS, and this is what we had yesterday. Now you can see you asked before. These are all the things. ChennaRRRS, my name is ChennaRRRS. Like that you asked and it is answering. That means it is able to remember the previous conversation. Even though you close the session, even though you come back, even though you close the session, even though you come back. See, it is able to tell. Okay, so it is able to tell. So therefore, close the session, come back tomorrow and run this. It is able to remember. Run this, it is able to remember. That's it, that's it, that's it. Close the session. Come back tomorrow. Run it. You can see still it is able to remember ChennaRRRS. Okay, that's it. So that's about these different concepts available here. Now let's recap this. Let's recap this. We discussed LangChain memory. Agents, whatever we created till now, are stateless. But in the real time, it is important for us to make this as stateful. To make for stateful understanding, I just ran the application from platform openai.com. There is a chart, and you can see I just type bunch of the questions, and if I say what I asked before, then it is answering. That means it is remembered. Now, to make the agent stateful, we can use checkpointers, or we can handle using checkpointers in multiple ways. Using RAM, by using permanent, by using Claude, like that. So that's why memory concept using checkpointers we can done in a number of ways. First one is in-memory saver, which will put the information in the RAM, and that is available as long as your process, Python process, is running. Once your Python process is stopped, then that information is not available. That's why this is shorter memory. For that, we have done the exercise and shown you. We have done the exercise and shown all the end-to-end. Then what is the challenge with this in-memory? The challenge with this in-memory is that information is available as long as that Python process is running. If you close the editor and come back and ask the same question, it says that I don't know what is that. That means it forgot. So how to put the information permanently? Okay, how to put the information permanently? For that also a number of ways are there, but right now I want to do using SQLite local database. Okay, SQLite local database. For that also we have seen end-to-end exercise. Then we can use Redis. It's kind of a caching mechanism. For production, we'll use this Cloud DB like that. So therefore, memories are three types: two types: shorter memory, long-term memory. For this, we have done the exercise. For this, we have done the exercise. Now, if anyone asks what is the check pointer, is the point. It tells starting of the save state. Then using that, it can execute the or resume the execution, persist the flow, continue the flow, and so on. Then we have seen the shorter memory example, which is a in-memory saver. It can remember as long as that process is running. Once you process is done, then if you run it, it cannot remember. That's what we have seen. And this is what it is. Now we are using SQLite database. It's like a permanent memory, long-term memory by using SQLite. SQLite is what? It's a local database. Then we coded it, and you can see all these are good. Now SQLite is a local database, right? SQLite is a local database. That means we should see that check pointers. Right now SQLite is our local database. It's a local database, and we kept the state inside this. That means we should see the output, or we should see those check pointers. Let's see where can we see that check pointers. Okay, we should see the check pointers. Let's see where can we see. So you can go to here. If you see one thing, when you create a connection, line number 18. When you create a connection, line number 18. So what is the name we have given? ChennaRRRS CP SQLite. So you can see ChennaRRRS CP SQLite. That's the name we have given. So go to that. ChennaRRRS SQLite. ChennaRRRS SQLite. See, open anyway. Using SQLite editor. Yes. Can you see this one, please? So ChennaRRRS. Okay, ChennaRRRS SQLite. Now you can see these are all the different threads. RRRS M1, M1, then M2, M2. So in this M1, how many messages are there? With the thread 2, how many messages are there? With the thread 3, how many messages are there? All the information is kept in this check pointer. All the information is kept in this check pointer. In a simple word, check pointer is the table right now. Okay, check pointer is the table right now. You can see. Check pointer is the table. In that, with the thread 1. Okay, with the thread 1, how many messages are there? If you go to the code, so right now with the thread 3, how many messages are there? Can you count it once? With the thread 3, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 messages are there. Let's run this one more time. Okay, I am running one more time with the thread 3. Okay, now what is happening? If you go here, you should see 10 right now. Okay, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So that means whatever relevant messages, it's not only 10, it can be more also because there is a multiple conversation for every request. So therefore, all the information kept in the 10 check pointer table. So therefore, if anyone asks what is a check pointer, it's kind of a table which has all the thread information commits. Which has all the thread information commits. And if you want to see the writes also, you can see what all is written. Okay, you can see this, 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 like this. You can go and check all these things here. So if you see what is this, okay, this is not required. Short term, these are not required. Okay, for us that name whatever we have given, that is important. Okay, so this is the name, RRRS check pointer SQLite. That's the name we have given. So if you see here, when we coding, yeah. Okay, ChennaRRRS check pointer SQLite. That's the name we have given. So with that, DB connection got created. Okay, so then we are trying to keep all the information using check pointer. It's kind of a table. Using check pointer, it's kind of a table. Okay, so that is the one we are passing to the agent, and that is the one we are using. Okay, we have passed to the agent. Then we created a thread because we can have multiple threads also. Using that thread, we are able to commit different information. We are able to commit different information. In a simple word, this is nothing but a conversation. If you go to the DB, whatever you have here, okay, you can also see that check pointers is the table. So these commits, these are nothing but conversations. These are nothing but conversation. That's it. So that's how we can work with the long-term memory, short-term memory, all those things. Now let me show you the notes till now. Okay. So if you see here, this is what we discussed: short-term memory, long-term memory. For short-term memory, we have used in-memory saver, and we exercised it. For long-term memory, we have used SQLite saver, and we have done the exercise. Or SQLite check pointer, we have done the exercise. Then types of memories, types of check pointers, and so on. Then if you don't use anything, by default it's a stateless. For that we have done the exercise. Then by using in-memory saver, we have seen how to put the state in that and retrieve it as long as that Python process is running. This is very important. As long as that Python process is running, that is very important. If the Python process is completed, then you cannot retrieve back. That's the challenge. So if you want it, keep that permanently, like a SQLite check pointer. For that, we have installed one additional package. And remember that that SQLite is a local database. Okay. Now we have installed one additional library for that. Then we activated the SQLite check pointer. Okay. Then we created an agent by passing the check pointer, and we invoked by using that thread ID. And then we tested back and forth. That means I just ran it. It is able to remember. I close the editor, come back, ran it. It is able to remember because it's stored in the file. As long as this file is available, as long as this check pointers information is available, you can able to retrieve it. You can able to retrieve it. That's it. That's what we practice. That is what we exercise. Then there is one important question. What is ReAct pattern? ReAct pattern. This is one famous interview question here. We already done the exercise for it. We just need to understand it. That's it. We already done many exercises with the ReAct design pattern. ReAct design pattern or ReAct pattern. Lots of people are asking the question, what is ReAct pattern? We done the exercises, but we need to remember in the answer format, question answer format, so that you can able to explain to the interviewers. What is the ReAct pattern? ReAct pattern is nothing but if you see here, means reasoning, act means acting. So that means reasoning and acting is nothing but ReAct pattern. And let's say I am giving like this here. So my question is, my question is like this. What is 2 plus 9 into 5? 2 plus 9 into 5. This is the question. If this is a question, is it a one-step process or is it a multiple-step process? Obviously, it is a multiple-step process. What happens internally? Internally, 2 plus 9 is done first, which is 11 is the answer. Then that is multiplied with 5. Then we get 55 is the answer. That is multiplied with 5. Then we get 55 is the answer. Then we get a 55 is the answer. Now if you see here, first reasoning, when we give this question to the model, when we prompt this to model, now model first thinking, oh, what is the next step I need to do? Okay. Oh, next step is 2 plus 9. That is called acting. Okay. Now 11 is there. 11 into 5. Again thinking what to do. Oh, multiplication. 11 into 5. Let me do the multiply. So that means there is a reasoning, means analyzing, means thinking, and there is acting. Reasoning means what? What to do next? Thinking, reasoning. Once reasoning is done, once thinking is done, once reacting, reasoning is done, then that actual operation, like 2 plus 9, 11, 11 into 5, 55. Those are called acting. Tools execution, performing the task. So therefore, LLM means model is a reactive pattern. It will think and act. It will think and act. And also it will observe what to do next. And is it done one time? No, right? First, it is thinking, oh, what to do next? 2 plus 9. Let me perform 2 plus 9, addition. Again, it is thinking next. What is next? Oh, 11 into 5, 55. Let me call the tool. Let me execute it, 55. Like that, it is thinking, reasoning, acting, and repeating until task is completed. So therefore, if anyone asks a question, what is ReAct pattern? Thinking, acting, observing, repeating. 4 sentences you can tell. Okay. 4 sentences you can tell. First one is what? Thinking. Is also called as reasoning. You can start remembering these technical names also. Because sometimes people say reasoning, thinking, reasoning. Once think and reason, it will identify what is next. Act. That's nothing but tool calls. Means performing the action. So let me do one thing. Okay. Then observe. Then finally repeat until task is completed. Repeat until task is completed. First thinking. Thinking means what? Just now about. Think about what to do next. Acting. Tools. Think about what to do next. If you see this particular prompt, think about what to do next. Oh, identifying 2 plus 9. That's called thinking. That's called reasoning. And for 2 plus 9, we need to call the function. That function is nothing but tool. That is nothing but acting, performing. So therefore, use tool. Okay, use tools or provide the answer. Use tools or provide the answer. Provide the answer means 2 plus 9, 11. Once you get it, observe, look at the results. Observe means look at the results. Look at the tool results and see what to do further. Again thinking. Okay, again thinking. Oh, now 2 plus 9 is 5. Sorry, 2 plus 9 is 11. After that, there is a star 5. That means 11 into 5. Thinking. Again acting. 11 into 5, 55. Observe. After the results, after the tool execution. Do we need anything? No. If yes, continue. Continue. So this will continue until what? Continue until the task complete. That's it. So if anyone asks a question, what is a ReAct? Thinking, acting, observing, and repeating. That's it. That is what I explained here. And I just put the example also. Next, there are some interview questions here. We'll just go through high level so that this will help. This will help to answer some of the things in the interviews. First one is, how do you deploy LangChain in production? Okay, so please remember this. Please remember this. This is what we have. This is how we developed the agent. This is how we developed the agent. Once we develop the agent, pack this as a fast API and deploy. That is one thing. So we deploy agent as a, so the question is what? How to deploy. Okay, how to deploy LangChain in production. That's the question. For that, wrap whatever we developed as the fast API. Okay, so that means let's say this is what we developed. Wrap this as API. Wrap this as API and deploy it. So this is the answer. How to wrap this as API? We will see in the coming days. How to, whatever we developed, you need to wrap it as API. We call it as fast API. Okay, and deploy. So to do this, we'll see how to create fast APIs. How to create fast API. We'll see coming days. Next, whenever you are deploying into the production, try to use asynchronous calls. Asynchronous means what? Let's say you are calling and it is taking 2 minutes. Other people should not block for the 2 minutes. You call it, let the execution happens. I will call, let my execution starts, like that, asynchronous. Okay, add proper logging and tracing so that you can debug it. Next, store secrets in environment variables or cloud secret managers. So that means what? The next point is what? So if you see here, we have this environment variables, right? Where we have a key, all those things. These you need to put in the secret place. Let's take the OpenAI key. OpenAI key you need to put in the secret place. You cannot share that to everyone, because that is the one which is doing the authentication. After authentication, you are sending a request, model is responding. Every request is a token, or every request is a set of tokens. Every response is set of tokens. Every token in the request or response cost it. That's why you need to be very careful. Okay, so therefore wrap how to deploy or what are the steps we follow to deploy the application or agent whatever we created, wrap it as a fast API, try to use the asynchronous API calls, logging and monitoring, put the environment variables, all those things in the secret place. Next, finally one is, now you are deploying this into some other place, right? It's important for us to use, okay, it's important for us to track it. So therefore, use observability tools. Observability tools like LangSmith. Like LangSmith. How to use it? How to use it? We will see in coming days. That's it. So therefore, in a simple word, if anyone asks a question, hey, what are all you developed? How to deploy into production system? So you can say that okay, wrap it as a API. We call it as fast API and deploy. And once we deploy, we should allow application should allow asynchronous calls. We should put proper logging tracing, and we should put dot environment variables or personal keys in the secret place, and use the observability like a longsmith for monitoring purpose, all those things. Okay, next one more thing is that as I told, right, as I told just now also we are discussing, this is the model. Assume that this is the model. Now this is the agent, that is the model, and this is the agent, and you are sending a request and it is responding. Sending a request is nothing but what? Prompt, and it is responding. So prompt can have n number of tokens. We have seen how to find the tokens, all those things. And the response also can have a number of tokens. Each token is cost. Each token is cost. That means always the cost is number of tokens in the prompt, or number of tokens for prompt, number of tokens in response is nothing but cost. So therefore cost equal to or price equal to, okay, number of tokens used in the prompt, okay, number of tokens used in the prompt plus number of tokens used in the response. That is nothing but the cost. Now, is it important for us to reduce the cost? Obviously, yes. Is it important for us to reduce the cost? Obviously, yes, right? So that's why there is a famous interview question, how to optimize cost in LangChain applications. Optimize LangChain applications. How to optimize cost in LangChain application? This is very important question. Obviously, the first thing is that this is how we are sending the prompt, right? This is how we are sending the prompt. Okay, reduce the prompt size. Each prompt is a token or set of tokens. So therefore, reduce the, okay, so prompt size. Reduce the prompt size. What does that mean? The meaning is, let's say I want to ask about Python here. Let's say I want to ask about Python. Then, okay, let's say I want to ask about Python. You can see once. Okay, I can ask what I am working in, or one way I am learning Python right now. Okay, please help me with the Python by answering in one line. So this is how I can do. Okay, I am learning Python right now. Tell me Please tell me what is the please tell me what is Python by answering in one line. Like that, I can do the prompt. See, I will get the response. Okay, I got the response. This is the response. But here, prompt is very big. You can see big prompt is there. Okay, so then more tokens. More tokens. How to calculate the tokens we already seen. Now, instead of this, you can also ask like this, right? Explain Python in one line. Explain Python in one line. Like that also you can do it. Like that also we can do it. Like this also we can do it. Now when you run, there are extra, there is a syntax type. Okay, now run this. Now also we got the answer. Now also we got the answer. Then which is a better? Obviously, this is a better one. Like this, you need to reduce the font. So less tokens. See here more tokens, here less tokens. This is the bad practice. This is the best practice. First one is a bad one. Second one is a best practice. You can also observe the results. So when I say explain Python in one line, this is the response we are getting. What is the response? Okay, you can see this is the response we are getting. Okay, let me use that big prompt. Let me use this big prompt and see is there any difference in the response. Mostly same response. Mostly same response. I just executed. Now this is what we got it. Go here. Go here and try to observe. This is with less prompt. This is with more prompt. Python something, and you can see here. That's it. Almost the same response. Like this. So therefore, it is important for us to reduce the prompt. We have done. Then the second one is summarize memory. These are all we will practice it. Summarize memory. We'll practice in coming days. Summarize memory means what? So let's go to the platform OpenAPI. Platform OpenAPI. You can see I ask tell about India, tell about Python like this. Do you want to keep all the information or summarize it? Obviously summarize. Otherwise lots of tokens will be back and forth. If there is no summarization, lots of tokens will be back and forth. That's again a bad practice. That's why, so summarize memory is important. How to do it, we'll see in the coming days. Next, you can cache it. Cache the response. So instead of, let's say you are asking same question. You also remember, right? Many times we restarted the editor. Why we restarted the editor? I said it's cached. So we need to implement the cache so that whatever needed will be getting from model, remaining can be taken from cache. That way also number of tokens back and forth will be reduced. Number of tokens back and forth reduced means obviously cost is reduced. Next, use cheaper models for retrieval. Okay, use cheaper model for retrievals. What does that mean? Use cheaper models for retrievals. Okay, what does that mean? Let's go to this platform OpenAPI. Let's go to this platform OpenAPI. And let me start a new chart. Okay, platform open API, or let's go to the platform open AI and chart. I'm starting a new chart. When you start a new chart, you can see right now the model is GPT 5.5, GPT 5.5, which is the latest but can be costly. So let's say I ask about explain Python in one line. I got the answer. Okay, so right now GPT 5.5, I got the answer, but it is little costly to use because it has more tokens, more better database like that. I can also do the same thing with mini models. Let's say GPT 4 dot, okay, GPT hyphen 4, 4 dot mini. I can get the same thing with the GPT 4 dot mini, but it's a less cost. Explain Python in one line. You can see I got the answer, but here the cost is less. Now you can ask a question, why are we using GPT 5.5? Because it's a more accurate one, more updated one, more latest one. So that's why you can see here once you can type GPT hyphen 4.1 mini trained training date. You can say training date. It was okay. It was you can see almost May or June 1st, 2024. 2 years back. 2 years back. It's not having that latest information. 2 years back. Now let's see the GPT 5.5. No mini. Directly use GPT 5.5. Just search it. You can see it is trained April 2026. Okay, April 2026. Don't use even mini also. So you can see April. Okay, April 2022, 2026. This is May, right? May, June, 2 months back. So that means it has more latest one, more brain, more information like that, and it's costly. Now you can ask a question, why can't I use every time this GPT 4.1? Because it's a less cost. Obviously, right? This was trained 2 years back. It may not have more information, more brain, okay, latest information like that. Now depends upon the situation. Try to use the better model. That's the answer. Depends upon the situation. Try to select the better model so that cost will be less. So that cost will be less. This is very important here. Depends upon the requirement. Try to use the depends upon the requirement. Try to use the best model so that your cost will be less. Okay. Next, fifth one is like this. We can reduce the cost. Control the top K retrievals. Control the top K retrievals. What does that mean? We'll see later. But in a simple word, this is a very famous question, how to optimize the LangChain application or LangChain agent application. If anyone asks, you can tell that reduce the prompt size, do the memory summarization, cache points or cache response. Okay, try to use the best model suitable for the current requirements so that it will reduce the number of tokens and control top K retrievals. Like that, you need to try to answer. Like that, you need to try to answer. That's it. Next. There is one more famous question, how to reduce or prevent hallucination in LangChain. What is the meaning of hallucination? I already explained. Model is nothing but a brain. It has lots of information. It can assume it. It can assume it and give it. Then how to avoid the hallucination? You remember we got some unexpected response also from model. because it is assuming and giving. It is assuming and giving. We have practiced. So therefore, the next question is how to avoid that hallucination responses in LangChain. This is also one more famous question. How to prevent hallucination in LangChain. Obviously, if you don't want hallucination, use your own RAG. What is the meaning of RAG? We'll practice in coming days. So that means in a simple word, instead of retrieving data from model, you can retrieve data from your documents. So that means right now, whenever you send a request, right? Can you see this one? Let's say this is the model. This is the model and this is the agent. This is the model and this is the agent. Whatever you request, it will go and get from model. Whatever you request, it will go and get from model. That is what we have right now. So sometimes you can also go with the internal databases, internal documents, and get it from there. Internal documents and get it from there. Okay, internal documents and get it from there. That's called RAG. How to do the RAG implementation, we'll see in coming days. So in a simple word, how to prevent hallucinations? How to prevent the hallucinations in LangChain? So the first one is use RAG. So that means if there is any document information needed, let's say I am asking a question, what is travel policy? What is travel policy? That is the question I'm asking. Now instead of getting from model, you can get from internal documents called RAG. Okay, so we'll practice this in the coming days. Then we want to prevent hallucination, right? So limit responses to retrieve context. So you need to, instead of say explain Python, if you say explain Python, it can, let's go to here. Okay, so I'll just type explain Python. If I type explain Python, you can see I'm getting big response. Then there is a possibility of hallucination. There is a possibility of hallucination. That means the probability increases. So that's why limit the response to retrieved context. Let's say now I'm saying Python, explain Python in one line. Then it can give more accurate results. More accurate results. That the probability is increases. That's the thing. Okay, the probability get increases. That's it. Next, third one. So here we have system prompt, right? Set the tone. Okay, use the system prompts. Set the tone. Use the system prompts. Set the tone. We practice this a lot. So I'm just trying to repeat those to answer the questions in the interviews. That's it. Okay, so use the system prompts. So use the system prompts means even though you type, let's say, going forward, system prompt, going forward, explain Python technology. Going forward, explain Python technology. This is how I set the tone. Now, whatever questions you ask, it will give around that only. Let's say I'll go here, ask the question, best learning today. Best learning today? See, it is giving about Python. By mistake, I typed best learning today. Okay. If I don't have the system prompt, then you will get the hallucination answer. Let's say I don't have the system prompt. Let me type a same question, best learning today. See, it is giving something else. It is giving something else. So that's why try to use the system prompt, which is nothing but the tone of that particular conversation. So that so that hallucination can decrease, so that we can prevent the hallucination. Okay, that's it. That's about this. Next, these are the things we practice here. Only thing is that I am trying to put as a question answer so that you can answer the interviewers easily. That's it. So the next one is validate output using parsers. So this also we completed the exercises. Validate the output using parsers. So don't take all the output, validate it. If it is meaningful, then use it for back and forth. If it is not useful, why you want to use it for back and forth? Okay, next. So there is a temperature here, right? You remember temperature. Where is that? Let me go and select the model. This is the model. And there is a temperature. Temperature here. High temperature means more creativity. Okay, temperature. We studied this already. Enough. Okay, temperature. That's why even when we write the agent also, if you see in the code, when we write the agent also, we are passing temperature. Temperature 0. That means low temperature. Low temperature means realistic accuracy, more accuracy. Realistic accuracy, more accuracy. Temperature high, like a 1, 2, like that. Then more creative, more randomness, more hallucination. So therefore, temperature low. If you put low value, that means temperature equal to 0. Then realistic accuracy. Temperature high, that means you are putting 2. So right now values are 0 to 2, right? You are putting 2, temperature high. So more creative or more randomness, like that. So therefore, if you want a less hallucination, prevent hallucination, what you need to use? More or less? You need to put a less, which is 0. If you put a 0, if you put less temperature, then it will give more accurate answer, realistic answer, which prevents the hallucination. Okay. Like this, you need to have, or you need to prepare question answers also, so that you can able to answer the interviewers clearly. That's about this one. Then there is a one more famous question: what LangChain, or what is a LangChain tool? Anyway, we understood all these things already. What LangChain tool? Okay, what is the advantage? That big picture also we have seen, right? Okay, so therefore, using LangChain, we can develop the agents that can talk to functions, that can talk to APIs, talk to databases, external sources, and do the talk to the models, do so many things. That's what we are practicing from last couple of days. That's all about today. If you have any questions, go ahead and ask. Else, we are good for today, and we'll continue tomorrow. Thank you.